Welcome to an inside look at Fuji's new KR concept, a chance to see firsthand the evolution of a new concept in rod component technology and design. Using Fuji's new tangle-free K-series design, researchers have gone back to the drawing board with two key factors in mind. First, ring size, a critical concern in many of today's rod designs and the subject of much debate. And second, frame height, a critical feature of guide position and performance in spinning rod design. Data was collected using actual human casting and a variety of machine casts. Engineers chose stiff fluorocarbon line as the ultimate test of their research. The research was based on evaluating current trends towards smaller guide trains. Only then could Fuji engineers address modifications of the original new guide concept. The first area examined was the idea of reducing line coils through a series of progressively smaller rings, a concept from the cone of flight theory, and also seen in Fuji's new guide concept, where multiple guides are used to reduce the line coil to a predetermined choke point. From a variety of angles, it's easy to see that this guide layout technique allows an erratic line flow to travel far down the rod. The coils of line pass through the stripper and on to the next slightly smaller ring. The result is a choppy, erratic line flow with bits of energy being lost at every guide. One of the most recent attempts to solve this problem uses a smaller ring reduction train to control line sooner. In theory, this seemed to be a suitable solution. In practice, new problems arose. Existing smaller ring strippers were lowered to the blank. Placed close to the reel, the sharp downward angle created bunching and introduced an unacceptable level of line slap against the blank. Moving the stripper out eliminated bunching but worsened line slap. In addition, using current new guide concept suggestions called for slowly stepping down the line coils through a series of smaller rings, which resulted in the erratic line flow continuing from one guide to the next throughout the entire reduction train and even into the running guide. Clearly, design modifications needed to be made. After a year of further study, the KR concept emerged as the future of rod component technology. KR strippers had small rings and much higher frames, which contributed to much faster line control. Subsequent guides had less erratic flow to manage and smoothed line flow even more. By the third reduction guide, line flow was fully managed and flowing smoothly along the blank. Additional testing and high-speed photography further revealed that line was controlled so quickly using a higher frame and smaller ring that traditional choke points could be moved closer to the reel. Smooth flowing line could be moved downward and along the blank much quicker with no loss of energy. Fuji researched and refined this discovery into a new choke point placement strategy called rapid choke. Rapid choke produced a perfect flow along the blank, and engineers began to work with smaller running guides to harness and maintain the straight line travel created by the reduction train modifications. Size 4 or 4.5 running guides proved optimal for most rods and became the recommended running guide for the KR concept. Shorter reduction trains created longer running trains, which caused higher mid-rod stress to small running guides. Fuji's final development was a wide-footed KB runner to handle these increased stresses. The new KR concept is made up of size 4 or 4.5 running guides, a specialized runner just after the reduction train called a KB, and a unique high-frame, small-ring, rapid choke reduction train. It adds up to the most advanced spinning rod layout technique ever developed, the KR concept. The next challenge facing engineers was KR concept casting. Casting presented a new set of questions to explore and a new set of accepted standards that needed to be challenged in a laboratory setting. The first challenge was an examination of currently accepted guide layouts for casting rods. The question being, are the currently accepted large ring multi-guide reduction trains needed when the line is controlled by the reel-mounted line guide on the pawl gear? High-speed photography revealed the answer. For both moving and stationary pawl guides, when the line changes direction on the spool, an erratic wave pattern develops. Regardless of the reel, this wave always occurs. The current trend would suggest a reduction in the size of the stripper, but it became apparent that a very small, very low stripper could not handle the small wave created by the directional change in the spool, and actually created more line slap and bunching than the original larger ring stripper. It was further noticed that it even allowed a friction-causing wave between small downstream running guides. A better solution was needed. The answer was KR concept for casting, a smaller ring approach that still included a two-step reduction train to smooth the initial flow from the casting reel spool, followed by small ring running guides that maintain the control of the line throughout the cast to the tip of the rod. The improvement was instantly visible in high-speed photography. The chosen ring was small enough to control flow, large enough to handle the waves coming from the spool, and high enough to avoid bunching and line slap. A size 10 double foot KW. Further experimentation proved that one additional KW 5.5 would remove the last of the wave introduced by the reel. The KR concept was complete. Spinning? Or casting? The new KR concept from Fuji. The lightest, strongest, most powerful, most sensitive, longest casting rod layout concept ever offered.